Let's calculate for a location.
సార్ నాకు నిన్న సైక్రోమెట్రిక్ చార్ట్ ఒకసారి మళ్ళీ ఎక్స్ప్లెయిన్ చేస్తారా?
నిన్న క్లాస్ అటెండ్ అయ్యారా మీరు?
లేదు సార్, నిన్న కొంచెం లేట్ అయింది నాకు అటెండ్ అయ్యేటప్పటికి.
రికార్డింగ్ చూడండి సార్ ఒకసారి.
రికార్డింగా?
ఆల్రెడీ రికార్డింగ్ మీకు అవైలబిలిటీ ఉంటుంది.
ఈ సెషన్లోనేనా?
నిన్న సెషన్ ఓపెన్ చేస్తే కింద రికార్డింగ్ సెషన్ ఉంటుంది.
యాప్ ఓపెన్ చేయగానే అంటే క్లాస్ అయిపోగానే యాప్ ఓపెన్ చేస్తే వస్తుంది సార్?
అవును. ఏ సెషన్ ఏ రోజుకి ఆ రోజు రికార్డింగ్ ఆ సెషన్లోనే ఉంటుంది అనమాట.
ఓకే సార్.
చూడండి, అర్థం అవ్వకపోతే చెప్పండి, మళ్ళీ చెప్తాను.
ఓకే సార్.
So yesterday we found the values, right? Today we are going to find with respect to the location. For Hyderabad location, dry bulb temperature is around 104 degree Fahrenheit and relative humidity is around, humidity ratio is around 130 grains per pound. Okay, here it is 50 degree Fahrenheit and 45 degree Fahrenheit. Coming to the comfort, is 24 degrees centigrade and RH is 50%. So find out the remaining values, sir. Make it fast. Find out the remaining values.
కొంతమంది స్వభావాలు
तो सिर्फ वेट बल्ब टेम्परेचर दिया हुआ है, दूसरा कोई डेटा नहीं है, वो कैसा करेगा वो?
कहाँ? विच वन?
सेकेंड वन, वेट बल्ब टेम्परेचर।
सर
इसको कौन सा डेटा? वो ड्राई बल्ब 104 लिखेगा।
सर विंटर पे 50 डिग्री फ़ारेनहाइट इज अ ड्राई बल्ब टेम्परेचर, वेट बल्ब टेम्परेचर इज 45.
ओके
And remaining you find relative humidity, humidity ratio and dew point number.
ओके अंडरस्टैंड।
Yeah.
ओके
సార్ నేను మళ్ళీ యాప్ ఓపెన్ చేశాను. అదే
Sir,
నేను క్లాస్
నేను ఇచ్చిన లింక్ ఓపెన్ చేశారా?
మీరు ఇచ్చిన లింకా?
ఆ లింక్ ఓపెన్ చేస్తే ఒక క్లాస్ ఓపెన్ అవుతుందా?
ఒక నిమిషం. అవును సార్ ఓపెన్ అయింది. ఓపెన్ ఇన్ మొబైలా?
నేను ఇచ్చిన లింక్ ఓపెన్ చేస్తే మీకు లిస్ట్ వస్తుంది.
లేదు సార్, రిఫ్రిజరేషన్ సైకిల్ అని వచ్చి మామూలు అలా వచ్చింది.
లిస్ట్ వచ్చిందా మీకు?
లిస్ట్ రాలేదు సార్.
ఏమొచ్చింది ఒకసారి స్క్రీన్ షాట్ పంపరా గ్రూప్లో?
సార్ ఇది స్క్రీన్ షేర్ అవ్వట్లేదు.
స్క్రీన్ షాట్ పంపండి. స్క్రీన్ షాట్ గ్రూప్లో, వాట్సాప్ గ్రూప్లో పంపించండి.
వాట్సాప్ పంపించండి సార్.
ఇది ఇవాల్టి క్లాస్ కదా. ఇప్పుడు పైన 3 బటన్స్ ఉన్నాయి, అది ఓపెన్ చేయండి. 3 లైన్స్ ఉన్నాయి కదా, అది క్లిక్ చేయండి. మీకు నిన్నటి క్లాస్ ఓపెన్ అవుతుంది.
ఇందులోనే సార్. ఓకే, మెనూ
ఓపెన్ చేస్తే మీకు నిన్న ఎస్టర్డేస్ క్లాస్ ఉంటుంది చూడండి.
సార్ ఓకే సార్, వచ్చింది.
Secondo modo.
నాకొద్దు.
आंसर नहीं गया सर।
बोलो वेट बल्ब कितना है इधर?
81 फारेनहाइट सर।
81 डिग्री फ़ारेनहाइट। रिलेटिव ह्यूमिडिटी?
हाँ, रिलेटिव ह्यूमिडिटी 30%।
34%.
ओके, ड्यू पॉइंट 74 डिग्री फारेनहाइट।
विंटर पे
विंटर में रिलेटिव ह्यूमिडिटी 68%।
रिलेटिव ह्यूमिडिटी कितना?
68।
60%.
60 आता है। ह्यूमिडिटी रेशियो 35।
हाँ
ड्यू पॉइंट टेम्परेचर 40 डिग्री फारेनहाइट। 40।
नेक्स्ट दिस वन
21 डिग्री फारेनहाइट।
एक बार अच्छा देखो क्वेश्चन. व्हाट इज द क्वेश्चन दे हैव गिवन?
ड्यू पॉइंट टेम्परेचर 24 डिग्री।
ड्राई बल्ब टेम्परेचर
ड्राई बल्ब टेम्परेचर 24 डिग्री।
it's 24 degrees.
रिलेटिव ह्यूमिडिटी
You need to convert into Fahrenheit.
ओके ओके ओके
75
डिग्री टू कन्वर्ट 75 डिग्री फारेनहाइट।
now find out.
ओके ओके सर अभी बताएगा। हेलो
Yeah, tell me.
सर 75 ड्राई बल्ब टेम्परेचर है ना, वेट बल्ब टेम्परेचर 63।
53 or 63?
63
63 degree Fahrenheit.
Humidity ratio 65 grains per pound. Dew point temperature 55 degree Fahrenheit.
Okay.
एक वैल्यू गलती हो गया, रिलेटिव ह्यूमिडिटी 64 ले गया। रिलेटिव ह्यूमिडिटी
Honey, you please be on mute.
ओके।
Okay. Now, summer dry bulb temperature is 104. It may be lying around here. वेट बल्ब कितना है? (81 degree Fahrenheit) and relative humidity is 34%. And 130 grains per pound. Next, coming to winter, we have 50 degree Fahrenheit, so which is lying around here, and 45, 60%, 35 grains per pound. (75 degree Fahrenheit), 63 degree Fahrenheit, 50%, is 65 grains per pound. Now, summer पे हैदराबाद condition इधर है. The Hyderabad condition is here in the summer, but comfort condition is here. So that means we need to shift this point to here. Okay. To shift this point to here, so what is the process we need to go? First, I need to shift this point to here. So that means decreasing of temperature. What is decreasing of temperature? What is the process? If I go with the process of decreasing temperature, what it is called? If I decrease the temperature, what the process it is called? It is called as cooling. Okay, it is called as cooling. Here we have sensible cooling. Now this point shifted to here. Now I need to shift from here to here. So we are removing the water vapor molecules, which is called as dehumidification. That means for location Hyderabad, for summer, we need cooling and dehumidification process का जरूरत होता है. Now this point should shift to here, so that we need to increase the temperature, so which is called as heating. Sensible heating. Now we need to increase the water vapor molecules, which is called as humidification. So for Hyderabad location, we need heating and humidification process for winter, cooling and dehumidification process for summer. So this arrow mark representing cooling, right? This arrow mark representing heating. This arrow mark representing humidification, and this arrow mark representing dehumidification. Now for Hyderabad location, summer पे क्या प्रोसेस जरूरी है? कूलिंग एंड डीह्यूमिडिफिकेशन का जरूरत है. ठीक है. सो कितना टेम्परेचर को डिक्रीज करना है? सो वी नीड टू डिक्रीज -29 डिग्री फ़ारेनहाइट एंड -65 ग्रेन्स पर पाउंड. तो डिक्रीज करना है. दैट इज द रीजन वी आर रिप्रेजेंटिंग इट एज ए माइनस. नेक्स्ट, सो विंटर पे हीटिंग एंड ह्यूमिडिफिकेशन. So we need how much temperature we need to increase? 25 plus 25 grains per pound. Humidification के लिए 35 plus 30 grains per pound. हमको 60 है, इधर 35 है. So और 30 ऐड किया तो 65 हो जाएगा. इधर 130 है और 65 माइनस कर दिया तो 65 हो जाएगा. ठीक है. So this is how we summarize the process by using the psychometric analysis. We identify the process for particular location, which process is required for that particular climatic conditions. Okay, make a note of this table. Make a note. Done? Is it done?
लिखा है सर, बस हो गया
हो गया?
हो गया
Okay. The next concept is refrigeration cycle. So, refrigeration cycle is the basic or the mother of all refrigeration systems. The vapor compression cycle is mother of all refrigeration systems. So in the year of 1902,
सर ऑडियो बराबर नहीं आ रहा है सर, ऑडियो बहुत डिस्टर्ब हो रहा है।
in the year of 1902, okay, the first air conditioner was introduced by Willis H. Carrier. Okay, so the Willis H. Carrier is called as father of modern air conditioners. Okay, now at that particular time he didn't use any refrigerants, he used some coolants. But when the year 1950s came into the market, the usage of refrigerant started. Okay, here this is called as refrigeration cycle, because here we are using a refrigerant. What we are using? We are using a refrigerant. That is the reason it is called as a refrigeration cycle. So what is refrigerant basically? What is refrigerant? Refrigerant is a heat carrying medium which always changes its phase upon heat exchange. Refrigerant is a heat carrying medium which always changes its phase upon heat exchange. Okay, so refrigerant एक fluid है. Okay, it changes its phase. its phase means vapor से liquid, liquid से vapor, वो होता रहेगा upon heat exchange. And what is cycle? Cycle is a closed path, we can say. So its starting and ending point will be at the same place, and repetition of functions happens. That is called a cycle. Here we are using a refrigerant in a cycle, in a repetition of functions, which is called as a refrigeration cycle. So in the market, we have different refrigerants. Thousands of refrigerants are there in the market. So in the thousands of refrigerants, the basic refrigerants are R11, R12, R22, R717. हमारा रेफ्रिजरेशन इंडस्ट्री पे ये रेफ्रिजरेंट्स बहुत ज़्यादा यूज़ करता है. R11 is trichlorofluoromethane, R12 dichloro-difluoromethane, R22 chlorofluoromethane, R717 ammonia. Okay, here when the refrigerants are existed in the market, trichlorofluoromethane, chlorine and fluorine, dichlorofluoromethane, chlorine and fluorine, chlorofluoromethane, chlorine and fluorine. So in the year of 1980s, the scientist has found that these refrigerants are responsible for ozone layer depletion. Okay, the thickness of ozone layer is decreasing due to these refrigerants. Okay, now as the refrigerants, the thickness of the ozone layer is decreasing, that is very harmful to human beings, right? What happens if ozone layer decreases? The thickness of the ozone layer decreases. What happens? What is the use of ozone layer?
सर ओजोन लेयर जो है सर हाई टेम्परेचर हीट को सर कंट्रोल करता है ऊपर का, एज ए सुरक्षा प्रोवाइड करता है।
हाँ, ओजोन लेयर का यूज क्या है सर?
ओजोन लेयर से सुरक्षा प्रोवाइड करता है, एज ए कवच, अर्थ के ऊपर कवच है एक टाइप का।
Yeah, it filters the ultraviolet rays.
यस
Okay, it filters the ultraviolet rays. Okay, if it is not able to, if the thickness of the ozone layer decreases, then it creates more harmful to the human beings. That's the reason in the year of 2004 they have banned this refrigerants. Okay, ये refrigerants को ban किया है, ठीक है? So while banning this refrigerants, they have provided some, what we can say, alternate refrigerants. Okay, so they have provided some alternate refrigerants. R11 के लिए R123A, R22 के लिए R134A, R22 के लिए R410A, ऐसा अल्टरनेट रेफ्रिजरेंट्स को वो लोग दिया है। नाउ so here the A represents the safety code of the refrigerant. Okay, the A represents the safety code of the refrigerants. So what is the safety code here? There are 5 safety codes for the refrigerants. Refrigerants को 5 safety codes है. Safety code 1, sorry, class A, class B, class 1, class 2, class 3. Class A, class B, class 1, class 2, class 3. Class A, okay, class A represents the non-toxic refrigerants. Non-toxic refrigerants class A represent करता है. Class B represent करता है toxic refrigerants. Okay, class B represent toxic refrigerants को represent करता है. Class 1 represents, okay, class 1 represents non-flammable refrigerants. Class 2 represents moderately flammable, and class 3 represents highly flammable. So if I write 1, 2, 3, R123, A3, that means non-toxic, highly flammable refrigerant. Suppose if I write 1, 2, 3, B2, that means toxic refrigerant and moderately flammable. So this is how the safety ratings has been given for the refrigerants. Okay, so coming to the refrigeration cycle. Okay, coming to the refrigeration cycle consists of many components. Okay, refrigeration cycle consists of many components like compressor, condenser, strainer, expansion valve, evaporator, accumulator, a blower and axial fan. Okay, blower and axial fan. So these are the different components which are connected by using a copper tube or copper pipe. Copper tube, copper pipe से ये connected है. Now this piping starts with the compressor and ends near to the compressor. You can see that it is starting with the compressor and ending with the compressor. Now, so these components of the refrigeration cycle has been divided into two different categories. ये दो categories पे divide किया है, primary components and secondary components. Primary components and secondary components. What is primary component and what is secondary component? Primary component is more essential to complete the refrigeration cycle. Primary component is more essential to complete the refrigeration cycle. Okay. And secondary components are helping components for the primary components, and secondary components without secondary components also. Okay, without secondary components also, the refrigeration cycle can work. The refrigeration cycle can work. Okay. Now, here the primary components are compressor, condenser, expansion valve, and evaporator. Compressor, condenser, expansion valve, and evaporator. And secondary components, secondary components are axial fan, blower, accumulator, and strainer. Axial fan, blower, accumulator, and strainer. Now let's start with the compressor. Compressor is called as heart of the refrigeration cycle. Refrigeration cycle का heart compressor है. So हमारा heart क्या काम होता है सर? What is the function of our heart?
Blood supply.
Blood को
Circulation. Whole of body.
ब्लड सर्कुलेट करता है, वो ब्लड को सक करता है और ब्लड को डिस्चार्ज करता है, वही है ना?
Yes.
इधर भी कंप्रेसर का काम भी वही है, रेफ्रिजरेंट को सर्कुलेट करता है ये रेफ्रिजरेशन साइकिल के अंदर. सो इट सक्स द रेफ्रिजरेंट and discharges the refrigerant. Compressor sucks the refrigerant and discharges the refrigerant. But in between ये कुछ और काम कर रहे हैं. In between it is also going to work. कुछ और function काम कर रहे हैं. The function is compression. The compressor compressing the high volume of the refrigerant. It sucks. Compressor sucks the high volume of refrigerant and it compresses to low volume and discharges. Suppose एयर पंप है हमारे पास, साइकिल का एयर पंप मालूम है ना आप लोग को. Whenever we pull back the piston of the air pump, the air gets accumulated into the cylinder, high volume of air. When I apply the force on the handle, the piston compresses the air inside the cylinder and the discharge will be with low volume and high pressure, right? Cycle pump से हवा कैसा आता है sir? High pressure air will come, right?
Yes.
Okay, same thing happening here. That is due to Boyle's law. Pressure or volume is inversely proportional to pressure. So it is discharging the low volume of the रेफ्रिजरेंट कंप्रेस करके लो वॉल्यूम को डिस्चार्ज कर रहा है सो दैट इधर प्रेशर विल बी वेरी हाई नाउ सो चार्ल्स लॉ Charles law. But Charles law is telling pressure is directly proportional to temperature. So that here temperature also will be very high. Very high temperature. And the refrigerant is completely in vapor state. Okay, the refrigerant completely in vapor state, so it is called as vapor line. So this is called as vapor line. Now this vapor high temperature, let me assume the temperature is around 80 degrees Fahrenheit or 80 degrees centigrade. सोचो अभी समझ पाएगा आपको. Now, this high temperature refrigerant will be supplied into the condenser. Okay, into the condenser. This condenser will be always outside of the condition space. ये condition space से बाहर ही होता है. ठीक है? This will be outside of the condition space. Now फ्रिज, आपको फ्रिज मालूम है ना, आजकल हर घर पे फ्रिज होता है. वो फ्रिज का पीछे एक ब्लैक कलर पाइप्स नहीं तो ब्लैक कलर का होता है, वो कंडेंसर होता है. ओके, वो कंडीशन स्पेस, फ्रिज का अंदर है कंडीशन स्पेस, फ्रिज का बाहर है नॉन कंडीशन स्पेस. सो ये कंडेंसर फ्रिज का बाहर ही होता है. लाइक दैट ये रूम को कूल करना है तो रूम का बाहर ही होता है. ओके, now to the condenser we'll be supplying cold air. मैं cold air को supply कर रहा है by using an axial fan. cold air means outside air बोलता है मैं, outside air. so outside air कभी कभी 40 डिग्री सेंटीग्रेड 30 डिग्री सेंटीग्रेड भी होता है ना. outside temperature is around 40 डिग्री सेंटीग्रेड, तब आउटसाइड एयर टेम्परेचर विल बी अराउंड 40 डिग्री सेंटीग्रेड, राइट. फिर भी वो कोल्ड एयर ही बोलता है उसको, क्योंकि दैट एयर टेम्परेचर इज ऑलवेज लेस देन टू द रेफ्रिजरेंट टेम्परेचर. सो नाउ यू विल गेट हॉट एयर आउट. Now this refrigerant temperature decreases from very high temperature to high temperature. तो up to 49 डिग्री सेंटीग्रेड तक आ गया. सोचो now high pressure. Now इधर क्या हो रहा है सर? व्हाट इज हैपनिंग हियर? हीट एक्सचेंज हो रहा है ना.
यस सर.
और वेपर का टेम्परेचर डिक्रीज हो रहा है ना. सो द रेफ्रिजरेंट कन्वर्ट्स इनटू लिक्विड, सो दिस इज कॉल्ड एज लिक्विड लाइन. So the process of converting from vapor to liquid is called as condensation, right? The process of converting vapor to liquid is called as condensation. So that condensation is happening here. Okay, that condensation is happening here. So that is the reason it is called as condenser.
What happened, sir?
What will be the function of a strainer? Strainer का function क्या होता है सर?
स्ट्रेनर का फंक्शन डस्ट पार्टिकल्स आता है ना, इम्प्योरिटीज.
Filtration. Okay.
Filtration.
When it is traveling, when the refrigerant is traveling inside, when the refrigerant is traveling inside the, what we can say, when refrigerant is traveling inside the copper tube, some scaling or due to impact, some metallic particles, due to pressure impact, some metallic particles may come out. That is the reason, if that metallic particles enters, okay, if that metallic particles enters into the expansion valve, it may block the expansion valve. That is the reason we use the filter or strainer to separate these metallic particles. Okay, now this liquid refrigerant will enter into the expansion valve. कहाँ enter हो रहा है वो? Expansion valve पे enter हो रहा है. Expansion valve का काम क्या होता है? Expands. Compressor का काम compressor है. So उसका opposite होता है expansion valve. Expansion valve expands. Sudden expansion takes place. Okay. Sudden expandly हो गया. Suddenly volume drop. Volume increase हो गया. Suddenly volume increase हो गया. तब suddenly pressure drop होता है. When there is a sudden pressure drop, sudden temperature drop भी हो सकता है. Very low pressure, very low temperature. Temperature may be around 5 degrees centigrade. Very low pressure, very low temperature. Okay, so suppose the best example for the expansion valve is the deodorant bottles. आप लोग का आदत है ना deodorant यूज करने का, ठीक है? When you spray on your body, okay, the deodorant, the volume of the deodorant increases, so that suddenly pressure drop होता है, suddenly temperature drop होता है. So that is the reason when you spray the deodorant on your body, how will you feel, sir? Deodorant आपका बॉडी के ऊपर स्प्रे किया तो आपका फीलिंग कैसा होता है?
कूलिंग होता है, कूलिंग.
वही है, सेम, क्योंकि सडन प्रेशर ड्रॉप, सडन टेम्परेचर ड्रॉप के हिसाब से कूलिंग होता है. और उधर क्या होता है कि द पार्टिकल्स विल बी इन लिक्विड एंड वेपर स्टेट, राइट?
ओके सर.
लिक्विड एंड वेपर स्टेट होता है. इधर मैक्सिमम लिक्विड एंड मिनिमम वेपर. सोचो 85% लिक्विड पे हो सकता है और 15% वेपर स्टेट पे हो सकता है. एग्जाम्पल, now this chilled refrigerant, okay, now this chilled refrigerant will be supplied into the evaporator. this evaporator will be inside the condition space. ये कहाँ होता है सर? Condition space के अंदर होता है. Now the blower, what blower used to do? The blower will suck the room air and will throw on to the evaporator. Room air को लेके आके evaporator के ऊपर थ्रो करता है. थ्रो कर दिया ना. Now as it throws, now this air will get cool down first. क्या होता है? पहले cool down हो जाता है. Will become comfort air. Now ऐसा comfort होना है, first cooling करना है. Cooling के साथ साथ what is this required? Cooling के साथ आपको कुछ और process का जरूरत है. What is the process required? Cooling के साथ साथ to make it comfort.
What asking sir again sir?
कूलिंग के साथ हैदराबाद लोकेशन सोचो. उधर हमें समर पे कंफर्ट देना है तो हमको क्या क्या प्रोसेस का जरूरत है?
टेम्परेचर सर मेंटेन करना पड़ेगा.
सर प्रीवियस क्लास इससे पहले ही बोला था मैं एक साइकोमेट्रिक टेबल बना के. वो नोट्स चेक करो एक बार. लास्ट समरी देखो एक बार, साइकोमेट्रिक समरी. एक बार बोलो, कूलिंग हैदराबाद लोकेशन के लिए क्या प्रोसेस का जरूरत है?
सर ड्राई बल्ब टेम्परेचर एंड वेट बल्ब टेम्परेचर सर इक्वल होना चाहिए.
नो.
सर सेंसिबल कूलिंग होना चाहिए ना.
कूलिंग तो हो गया इधर. और
नहीं, आपका वॉइस बराबर नहीं मिला. वो क्वेश्चन एक बार बताओ जी.
यार वी मेड कूलिंग राइट.
हाँ.
नाउ one more process is required to make it comfort.
One more process.
So what is the process required here? Cooling and dehumidification, right?
Okay.
Cooling चाहिए और dehumidification चाहिए.
Dehumidification चाहिए.
So here we make dehumidification. ये कॉइल का टेम्परेचर क्या है? ड्यू पॉइंट टेम्परेचर होता है. ये कॉइल का टेम्परेचर ड्यू पॉइंट टेम्परेचर होता है. So when the air comes in contact with this coil, the water vapor molecules which is present in the coil will convert into water molecules. Condensation होता है. वाटर वेपर मॉलिक्यूल्स कंडेंसेशन होकर वाटर पे कन्वर्ट हो जाता है. सो रूम के अंदर वाटर वेपर का वॉल्यूम डिक्रीज हो जाएगा. ठीक है. दैट इज द रीजन every air conditioner, the air conditioners इंडोर यूनिट पे एक ड्रेन पैन होता है. इधर से एक ड्रेन लाइन आता है. तो उससे वो ड्रेन लाइन से पानी आता रहता है ना, ड्रॉप 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 ड्रॉप, कभी देखा है आप लोग?
Yes, sir.
So that is due to dew point temperature of the coil and the dehumidification is taking place. So sometimes in the interview they may ask you a question, how dehumidification is taking place in the times of summer. So due to dew point temperature of the evaporator coil, the water vapor which is present in the room air is converted into condensed into water molecules, so that the water vapor volume is decreased in the room.
Okay, sir. Okay.
Now here low pressure will become very low pressure will become low pressure, and very low temperature will become low temperature, and this will become वेपर प्लस लिक्विड. अभी इधर वेपर प्लस लिक्विड हो जाएगा. So now this vapor plus liquid refrigerant will enter into the accumulator. Accumulator अंदर enter होता है. So accumulator separates vapor and liquid refrigerant. That means liquid refrigerant को separate करके सिर्फ वेपर रेफ्रिजरेंट को कंप्रेसर के अंदर अलाउ करता है. ठीक है. Accumulator will separate the liquid refrigerant and allows only vapor refrigerant to enter into the compressor. Suppose if liquid refrigerant enters into the compressor, that may damage the compressor. Why? Because liquids are not having the property of compression. Liquids are not having the property of compression. So we need to separate vapor and liquid refrigerant. Now this accumulator will be placed near to the compressor. Accumulator कहाँ होता है सर? Compressor के पास ही होता है. So what happens? So whatever the heat generated from this compressor, that heat is being absorbed by the accumulator. And the liquid refrigerant which is present in the accumulator will be converted into vapor, and that vapor also will enter into the compressor, and the cycle repeats till the compressor works. Okay, this is what the refrigeration cycle is. So this cycle is also called as vapor compression cycle. Okay, vapor compression cycle, and this cycle is mother of all refrigeration systems. ये cycle क्या है? Mother of all refrigeration systems. Okay, make a note, sir. One of the most important question, the refrigeration cycle. Draw this.